Section 1.2, basic classes of functions. So we're going to go through a couple basic functions of classes of functions. That's including linear function, polynomial function, specific quadratic function. We'll be looking at it, also piecewise function. So the first example, okay, we're going to look at linear functions. So linear equation y equal to mx plus b, which we're all very familiar with. So example one, write the equation of a line. Now there are three scenarios typically. Whenever anybody asks you to write the equation of a line, your goal is to come up with the equation y equal to mx plus b. No, so what you're looking for is the slope and the y-intercept. Now for this specific first question, the question provide you with a slope, which is good. That's our m, but it's missing the b, which is y-intercept. It gave you a point. So that point, the first point is x, the second number is y. So if you look at this equation, we are pretty much given everything except b. That's what we want. We want to solve for b. So the slope is, sorry, I have this opposite. The slope should be 3, and x should be -3, and y should be 2. So the result is 2 equal to -9 plus b, so b equal to 11. So once you have the 3, that's a slope, and b is 11, then our equation is y equal to 3x plus 11. Now, the second scenario is similar situation, except they didn't give you the slope. They give you 2 points. So basically, they want you to write the equation of a line given 2 points. Well, then again, we need to find m, we need to find b. So to find slope, we use the formula y squared, y2 minus y1 over x2 minus x1, rise over run. So we input our y2, which is this 2 right here, minus y1, which is 7, and on the bottom, the denominator, we take the 1, which is x2, minus -3, which is x1. When we do that, you get -5/4. That's our slope m. Then we can pretty much do the same thing like what we did the previous example. So we have a point. We have 2 points actually, and we have a slope. So which point do we pick? Either one, but in this case, probably this one is easier just because both points are on the same line. So it doesn't matter which point you use, but we're going to use 1 and 2. So just, it's a smaller number with no negatives. So we're going to put 2 for y. Our slope -5/4 is right here, and the x is 1 plus b. So when we solve for b, we get 13/4. So our final answer for this linear function is y equal to slope -5/4x plus by-intercept 13/4. Okay, now, do we know how to graph this? Well, we're giving a standard form of a line, almost standard form. Okay, the 15 is kind of out of place. But if you want to graph a line, the easiest way is to change to graphing friendly y slope intercept form. So we want to manipulate this equation into y equal to mx plus b. So we're going to keep y on the left hand side and move all the other terms to the right hand side. Then we divide by -5 everywhere. That's our equation now. So once we have the equation, the simple y-intercept is 3. So we're going to start at the 3 on the y, and the slope is rise over run. So it's 6 going up, 6 going over 5. So we're going to go out 1, 2, 3, 4, 5, 6 up, and then 5 over. That's our second dot. When you connect the line, then this line represents all solutions to 6x minus 5y plus 15 equal to 0. Now let's look at your polynomials. Okay, so in polynomials, you want to find zeros, y-intercept, and ending behaviors of a polynomial. Now, ending behavior, okay, if it's an even degree polynomial like x squared, x to the fourth, x to the sixth, all right, it's always going to look like this, okay, if your leading coefficient is positive. So if your leading coefficient is positive, you end up up on the left side and end up up on the right hand side. On the other hand, if it's even degree, but your leading coefficient is negative, then you will end up from the bottom and end up with the bottom. Now, on the odd degree, that means x cubed, right? X to the fifth power, x to the seventh power, so on and so forth. Same thing. If it's positive leading coefficient, you'll start on the bottom, end up on the top. And if it's negative, it's the opposite. You end up on the top, and your function would end up behavior wise will be on to the bottom. And be sure to look at the transformations. Refer to table 2 in the book as a review. So one of the questions they're going to ask you is, giving a function, do you know how to sketch it? So f of x equal to parentheses x plus 2 squared minus 1. Now, first of all, this square tell you is a parabola. So these are what we call the basic, the classic functions. You need to know what each one look like. So the square is definitely a parabola. Now, since our it's positive leading coefficient, so we know it's gonna, like, the ending behavior will be more like this one right here, right? So it's an even degree because x squared, and then it's gonna start on the top, end up on top. So that's what we can expect right here. Now, so once we know the shape of the function, and we know the ending behavior. Now, to notice and sketch it, you just need to figure out, well, parabola generally look like this. Now, we just need to know how that's why you need this table right here in table 2, the transformation work. This minus 1, taking your basic parabola, shift down 1, and then this plus 2 here is shifting left 2. So instead of parabola starting at origin 0, 0, it's going to shift down 1 and then shift over 2. So that's your new origin to your parabola. Now, piecewise function look like this, right? It's like it's a function that's broken into pieces, okay? And so it kind of follow two lines. So if you look at where zero is, it says anything that's zero or less than zero, it's going to follow line 4x plus 3. So this line right here, 4x plus 3, okay? Now, anything beyond that, after zero, not including zero, right? Because our solid circle is right here. So if it's not including the zero, okay, then we'll follow negative x plus 1. So the second line right here is negative x plus 1. All right, so that's the graph of a piecewise function. Now, to evaluate, well, we give it three. I give you three examples here: f of negative 3, f of 0, and f of 2. Now, f of negative 3, since negative 3 is less than 0, so we're going to use the first part of the function to evaluate. F of 0 also belong to the first function because x is less than or equal to 0 will follow this function. Versus f of 2, since 2 is greater than 0, 2 is greater than 0, so it belong to the second part of the function. So when we evaluate 2, we're going to plug in this bottom function here, so negative 2 plus 1 equal to negative 1.